Welcome to another session of functions, a revision video part 2. Watch carefully and enjoy this video. Now we have a graph of parabola and a straight line. We have the point B 30. The axis of symmetry of F is x equal to 1. What's our question? Write down the coordinates of the point C. Just 1 mark. Alright, so we have coordinates of B, that is 30. The axis of symmetry, look at that, axis of symmetry, x equal to 1. The equation of the axis of symmetry is x equal to 1. So looking at the x-axis, B is 30. So from 1 to 3, it is 2 units. So definitely the other x-intercept, which is C, must be 2 units to the left from 1. So we understand that it should be negative. The x-coordinate of C must be negative. So our coordinates -1, 0. 1 mark. Next question, determine the equation of f in the form y equal to x squared plus bx plus c. 3 marks for that. In the previous question, we already got the coordinates of c and we already have the coordinates of b. Those two are the x-intercepts. So using the x-intercepts, we can write down the equation of the parabola. The coordinates of the x-intercepts are available. Now we use the method of multiplication of the factors. Okay, x minus 3 times x plus 1, which gives us y equal to x square minus 2x minus 3. Determine the range of f, the y values of f. We can see that the minimum value will be on the turning point A. We have to calculate that. We know the x value of A. Now the turning point, the y coordinate of the turning point, we substitute into the equation of the parabola. So we get y equal to 1 square minus 2 times 1 minus 3, which gives us minus 4. Therefore, the coordinates of A will be 1 minus 4. So the minimum value is minus 4. Now we can say the range is more than minus 1 or greater than or equal to minus 4. Calculate the equation of G in the form y equal to mx plus c. G is a straight line. For the equation of a straight line, we need the gradient. Since we have A and B, it's easy to calculate the gradient of the straight line using the formula for gradient, m equal to y2 minus y1 over x2 minus x1. So we use that formula here. M equal to 0 plus 1. Minus of minus 4 is plus 4. Be careful. 3 minus 1 in the denominator. And we get 2. Use the calculators. Now the point, at least 1 point. We need only 1 point, but we have A and B here. We are going to use the point B because it was already available in the question. We calculated the coordinates of A, so better use the coordinates which is available in the question, that is B 30. So y minus y1 equal to m times x minus x1. That is the formula for the equation of a straight line. You substitute y1 is 0, x1 is 3, then we modify the equation and we get y equal to 2x minus 6, the equation of G in the form y equal to mx plus c. 3 marks. For which values of x will f of x is greater than or equal to 0? Now when we look at the graph of f, the portion over the x-axis is positive and the section below the x-axis will be negative. So we have identified these areas. Okay, we can also use this idea of putting positive or negative. So the question is to find the values of x for which f of x is positive, or where do we get the positive y value, and then we can find out the corresponding x value there. Now we notice that from minus 1 to towards left, the section of the function is positive. So x is less than or equal to minus 1 is one answer. Again we go to the other side. We can see again another section of the function f is above the x-axis. We have to mark it like that, positive. Now what is the x value there? It is greater than or equal to 3. So these are the two answers for fx greater than or equal to 0. Again the same graph, but the question is for which values of x will f of x divided by g of x greater than 0, not greater than or equal to, greater than 0, 2 marks. All these questions are actually very interesting questions, but easy marks. We have the graphs of f and g. Then we look at that. We already know that the upper part is positive, the lower part is negative, and what we are looking is fx divided by gx must be positive. So we can see the negative times negative or negative divided by negative will give us greater than 0, that is positive. All those areas with negative and negative downwards, negative divided by negative is positive. Okay, that is okay. Again, look at the right side. We have f is positive and g also positive. So positive divided by positive also will give us positive. But what is important? We want only the corresponding x values. So we start from -1 onwards. All gives us positive. But remember that the question is fx over gx greater than 0, not greater than or equal to. So we have to skip that particular point of C and B. So what is our answer? What are the values or which values of x? We have x greater than -1, but also x not equal to 3. Very beautiful question. Again, interesting questions. Easy marks. What is the question? For which values of x? Again, you are looking for the values of x. The question says x times f of x. Here, x times f of x must be positive. Okay. We go for fx. We can see the negative sections there. And the corresponding x is also negative. So negative times negative will give us positive, greater than 0. Negative times negative. But when we come to the other one, if you cross 0 and moving to the right side, the x values are positive. Positive times negative is not going to be greater than 0. So we skip that. Then coming to the point B, the x values starting from B, they are positive, and the fx is also positive there. So x times positive starting from B, we can get greater than 0. That is positive. So we summarize the answer. It's 2 marks. We have between -1 and 0 the x value. The x value must be between -1 and 0, and or x is greater than 3. Look at the values of x. So we get 2 marks. After practicing few questions like this, you will be able to score any question of this nature. That is the end of another session of functions. It's a revision. Hope you enjoyed this video. Please share and subscribe.